Welcome to the session on differentiation, increasing and decreasing functions. The objectives for this session are to use the derivative to solve problems involving increasing and decreasing functions. The derivative of a function can help determine whether it is increasing or decreasing. The function f of x is increasing on interval ab if f dash of x is greater or equal to 0 for all values of x such that a is less than x is less than b. And it is decreasing on interval ab if f dash of x is less than or equal to 0 for all values of x such that a is less than x is less than b. Let's take a look at an example. The function f of x equals x to the 5 plus x. Looks something like this. Notice that it is an increasing function, and it is increasing for all real values of x. Let's take a look at another example. In this example, we look at the function f of x equals x to the 4 minus 2x squared plus 1. This looks something like the graph you can see on your screen here at the bottom. Notice that the function decreases to the point x equals minus 1. Then it increases to the point x equals 0. So it is increasing on the interval minus 1, 0. Then it decreases to x equals 1. So it is decreasing on 0, 1. And then it increases again after x equals 1. Let's now take a look at another example. Show that the function f of x equals 2x cubed plus 5x minus 7 is increasing for all real values of x. So let's solve this. Now f dash of x equals 6x squared plus 5. If you've forgotten how to differentiate, note the rules for differentiation towards the bottom of your screen. 2x cubed differentiated becomes 6x squared, applying this rule. And 5x differentiated becomes 5. And of course, the minus 7 is going to be 0 when differentiated because it's a constant. Now, since x squared is greater than or equal to 0 for all real values of x, we have that 6x squared plus 5 is greater than 0 for all real values of x also. And therefore, f of x is increasing for all real values of x. And this comes from this statement shown here. Now let's take a look at another example. Find the interval on which the following function is decreasing. F of x equals 2x cubed minus 21x squared minus 60x. Let's solve this. Again, remind yourself of the rules for differentiation of polynomials, and then differentiate. So 2x cubed differentiated is 6x squared, minus 21x squared differentiated is minus 42x, and minus 60x differentiated is minus 60. So if we factorize, we obtain f dash of x is 6 times this quadratic shown. And when we factorize further, we obtain that f dash of x equals 6 times x minus 2 times x minus 5. So f dash of x is less than or equal to 0 when 2 is less than or equal to x is less than or equal to 5. And this is because x minus 2 is greater than 0 and x minus 5 is less than 0 in this interval. So when we multiply a positive and a negative by one another, we get a negative. Therefore, f of x is decreasing on the interval 2, 5, from this rule shown here. This brings us to the end of this session. If you have understood its contents, you should be able to use the derivative to solve problems involving increasing and decreasing functions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.